Good morning. I would like to thank you, namely Antonella Gasparini and Mauro Gargano, for the kind invitation to participate in this Congress here in Florence and for the perfect organization. The museum, the Mathematisch-Physikalischer Salon, I will use the initials MPS as a short form during the next half hour. The museum is among 14 other museums part of the Dresden State Art Collections. And it is housed in this wonderful building. It's part of the Dresden Swinger building, and it is housed there for nearly 300 years. So Dresden, here you see the skyline, and the river Elbe. Today we have much more water than this photograph. Dresden is the capital of the German state of Saxony and was before up to 18th century the residence of the Saxon princes and kings. And Dresden is the twin city of Florence since 1978. And since the 18th century, Dresden was called Elbflorenz, meaning the Florence on the river Elbe. So, and Dresden is settled in the southeast part of Germany. The MPS goes back to 1728 and is the oldest museum in the Zwinger complex. It was founded under Augustus the Strong, Elector in Saxony, and as August II, King in Poland, as his royal cabinet of the maths and physics. In my paper, I will use the short form with the initials MPS. Today, the MPS houses one of the world's leading collections of historical scientific instruments, horological instruments and automatas, and globes. The exhibits on show are outstanding examples of finely crafted scientific instruments and devices. The mechanisms and how they work is quite fascinating, yet they can equally be admired to their beauty. You can see it here in this reflecting telescope, which was built in the middle of 18th century in a small estate near Meissen, and the tube is covered with Meissen porcelain. The collected objects are following 5 main functions. First groups are the instruments to observe. So that means surveying instruments and telescopes, microscopes, and so on. The second group are the instruments to demonstrate. Here we have a mammillary sphere, is a permanent loan from the Anna Amalia Bibliothek in Weimar. And to this group, this group representing such devices like astrolabes, globes, planetaries, horaries, and so on. The third groups are the instruments to experiment. That means the philosophical instruments in a cabinet of physics. And here we have a vacuum pump by Georg Friedrich Brander, made in Augsburg at the end of 18th century. The fourth group are instruments to compare the Dresden Kunstkammer in the 16th and 17th century. So the whole collection runs back to the 16th century Kunstkammer. In the middle of the 16th century, Dresden became capital and residence in Saxony. Before that, Torgau and Meissen were the residences. And when Dresden became a residence, they erected a Kunstkammer, and this Kunstkammer was determined by tools and mechanical apparatus. And in the 60s and 70s century, the Kunstkammer took over the tasks that are now held in a calibration office. So reference standards were stored in it. And here we have standard lights made in the Friedrichsthal Glashütte at the beginning of the 19th century. The fifth group, and that's the most important for our collections, are the instruments to measure. So surveying plays an important role in our collection. Surveying instruments have been collected since the 16th century, and surveying was a core task in the collection until the 19th century. Proof to the importance of MPS-owned objects to articulate the course intellectual profile is the sumptuous volume Suite de Principes de la Géométrie, the 16 years old Prince Karl dedicates to his father. Here you see 2 pages or 1 page, the detail. So Prince Karl dedicates it to his father, August III, in 1749, as a harvest of his studies. In the most beautiful French handwriting, the prince comments upon drawings, explication, the principles of geometry, and the application in terrestrial and astronomical surveys as a result of his exercises. In the construction and function, the crescent-shaped instrument shown in the image corresponds with a semicircular instrument that belongs to our museum. It was made in 1690 by Louis Chapoutot in Paris, and very often instruments from the collection were used by the princely family to survey comets in the skies and Venus transits and something like that, but also to be taught in the surveying of the country. More than a century earlier, Christoph Schissler made this surveying instrument in Augsburg in 1569. As early as the 16th century, outstanding surveying instruments found their way into Dresden's Kunstkammer. The exceptional reliefs on the frame of these instruments illustrate that the instrument was used as a surveying device. Right triangles can be mapped in scale from onto the sides to the square. Christoph Schissler built this instrument in 1569 in Augsburg, and with the help of the laws of similar triangles, the instrument can be used to gauge distances that could not be measured directly. So, for example, the height of an inaccessible tower or the width of a river. The second instrument was made 10 years later in 1579 for the Imperial Court in Prague. This instrument was sold to England in 1603, and today it is shown on display in the Oxford History of Science Museum. And the third instrument, made by Schissler another 10 years later for the Fugger family in Augsburg, the third instrument was without the beautiful reliefs in the frame. Well, this last instrument was given at the beginning of the 17th century as a present to the Medici family and should be on display in the Museo Galilei here in Florence. The Dresden instrument was severely damaged in the bombing night of February 13, 1945, and the manuscript explaining the functions was burnt. Unfortunately, fortunately, photographs of the illustration have been preserved. Here you have two of these illustrations from the manuscript. In 1945, we lost most of our 16th century manuscripts. That's more than 200 highly interesting things. A few of them were photographed before. This is one of our exhibition rooms showing the instruments from 16th and 17th century. And here in the very first case, you have instruments and mechanical instruments for surveying. You see odometer, an itinerary scroll, and compass. And no, you can't see some drawing instruments. This brass-geared odometer used in a carriage worked in a similar way to a mileometer in a modern car. The distances covered was calculated from the number of wheel revolutions, multiplying by the circumferences of the wheel. The maximum measurable distance was 20 miles, 26 miles, that's approximately 180 kilometers. This one was made by Christoph Schissler in 1584, and I will give you some more information to Drexler. Was made by Christoph Drexler. I will give you a few more information to Drexler in a couple of minutes. It is highly probable that Elector August of the 16th century used this odometer made by Christoph Schissler on his journey from Mühlberg in Saxony to Regensburg in Bavaria in 1575. The counting mechanism is positioned at right angles to the dial plate and gears, making it easy to read off the distances on the horizontal positioned dial from inside the carriage. The maximum distance here was 15 miles. With all the collected information, the prince drew two different documentations of his journeys, maps and itinerary scrolls. Here you see a small part of an itinerary scroll. It starts in Mühlberg on the River Elbe, then they cross the River Elbe and get information about the direction, another river, and just like a small town are following. It took for the whole journey, it took 13 days to cover the approximately 54 Saxon miles. The scroll is therefore divided into traveling days from one overnight encampment to the next. The route is depicted as a straight line. Changes of directions are shown by means of compass roses. Along the route, the elector charted villages and towns, woods, rivers, and fish ponds, mills, and even gallows. The route scroll is 13.4 meters long and is one of about 50 such roads still existing. Not every town and village received its own woodcut. Occasionally, the print is used several times. So to show it as a village, you need a church, some houses, and a settlement group, not more. And then you can write the name of the place. It's not so important. Another group of instruments important for the Dresden court are gunners' levels, artilleristic instruments, probably to bring a cannon in the right position. This gunner's level, made by Christoph Drexler in 1572, was a diplomatic gift to the court in Prague, and is today not on display in the Kunsthistorisches Museum in Wien. It is one of the largest gunner's level made in the time around 1600. With the promotion of Christoph Drexler to an instrument maker, Elector August gained independence from purchases in Augsburg, and in particular from the leading instrument maker Christoph Schissler, who was based there. With two early gunners' levels, that's one of the two, Drexler created something like a genre of its own in the choir of instruments based on angular functions. The fact that this instrument is engraved with the electoral Saxon and with the Danish coat, the wife of August was a Danish princess. It was the daughter of a king, and in the hierarchy it was positioned over the electoral prince. These two coats of arms makes the Viennese specimen a remarkable diplomatic gift, quite worthy of an emperor, and thus probably delivered to the Prague court. Both Drexler, father, and his son of the same name built further gunners' levels in many variations until the 17th century, but they were considerably smaller than this instrument. Some of these instruments were also delivered to Florence and are now in the Galileo Museum. Here we have another exhibition room with philosophical instruments, and you see a group of burning instruments, so burning mirrors and burning lenses. These instruments are the unique selling point of the physical cabinet in our museum, which was set up in Zwinger in the 18th century. The firing apparatus shown in this picture came from Ehrenfried Walter von Schirnhaus, who discovered the recipe of Meissen porcelain with his experiments with these burning machines. In the last quarter of the 18th century, an astronomical observatory and time service for Dresden were added to this cabinet. Other philosophical instruments and philosophical and astronomical instruments came from a private collection into the princely property. So that's a view in the other direction, and this podest is filled with a group of instruments made in a private workshop in a castle called Schloss Reinhardt, north of Dresden. There, the Imperial Count Hans of Löser erected a workshop for constructing scientific instruments. The optical and physical devices manufactured there, mostly by Löser's own research investigations, were on a par with the very best contemporary products from Paris and London. Famous scientists even came from abroad to see Löser's instruments, despite the relatively remote location of the estate. After his death, the workshop was closed down. Most of Loser's instruments were taken to Dresden, where they considerably expanded the existing collection of the Mathematisch-Physikalischer Salon. Well known and often published is this reflecting telescope made in 1742. To better observe the night sky, Loser even ordered that the castle tower in Reinhardt's be heightened. Let me come to the outstanding globe collection of our museum. Here we have two interesting instruments. It's a world model with a celestial globe on the top made by Baldwin in Kassel in the 16th century. And here you have a Reinhold and Royal globe. I will explain in a couple of minutes more, show better pictures. To comprehend the celestial laws of the stars and planets, it's the oldest dream of humankind. Based on this, astronomers have surveying the sky, outlining mathematical theories in order to understand the movements of the stars in the most exact possible manner and attempt to predict it. In order to realistically envision the celestial processes without being compelled to undertake complex calculations, the Saxon elector acquired numerous exquisitely worked celestial machines. Actor Carl as the astronomical clock you see here, and his son Christian ordered a mechanical globe made in Augsburg. Here we have the two machines. For the princes, the extremely rare machines carried heaven on earth. Moreover, they symbolized something central vis-à-vis the legitimacy as rulers, their proximity to God. The Baldwin machine you see here in this machine on this globe, the Hessian Landgrave Wilhelm published his newly determined positions of the stars in the globe on top of the world machine. So a printed version of his new position, and I don't know if these positions are better than the old ones, were published not before the 18th century. For Wilhelm, mechanical globes made in metal were the form or the device to publish his new star positions and give them to universities and other courts. This machine, made by Johannes Reinhold and Georg Roll in Augsburg, they used for their celestial globe published positions, published mostly in Augsburg. Other versions of this globe are today on display in Vienna, in Paris, in London, in St. Petersburg, and in Capodimonte in Naples. And they are quite different. They don't look look the same. Our one has a complete provenance, so it came in 1587 to the princely collection, never left Dresden, so it's from the very beginning on. Here we have some details of this machine. So we have a mechanical celestial globe. On the horizon, we have both calendars. I think it's the only one of this 6 existing globes by Reinhold and Roll with both calendar systems. We have an armillary sphere on the top, a globe of the Earth. Here on the bottom, a compass and several sun dials. Here you see the image of the moon. And here you have the initials of Georg Roll, the movement of the machine. This is our globe room, and of course we have the most pairs of globes in several sizes published by Blau, Doppelmayr, Società, Coronelli, and so on in our collection. But we also have some special designs. Here, that's our oldest device. It's a celestial globe made at the end of at the end of 13th century in Persia, and it arrived in Dresden at the beginning of the 16th century. Second one is a globe. Ernst Fischer's lunar globe was made in Dresden in 1875. In the MPS, Johann Gottfried Köhler and later Wilhelm Gotthelf Glormann began at the end of 18th century their intense exploration of the moon's surface. Fischer's globe stands in the same tradition. And we have a globe of Mars after Schiaparelli's published map with a broad Mars canals. So, coming to the last two slides. The central person in the establishment of an astronomical observatory in the MPS in the 1770s was Hans Moritz von Brühl, in the United Kingdom, better known as John Morris Count Brühl. Brühl was a nephew of the famous Saxon Prime Minister Heinrich von Brühl. From 1764 on, he held the office of the Saxon ambassador in London, and from then on lived in England until his death in 1806. In England, the passionate amateur astronomer not only became a member of the Royal Society in 1765, but also an important patron of English instrument and chronometer makers, especially Jas Ramsden, Thomas Mudge, Joshua Emery. The portrait of John Northcote, shown here, was painted in 1796. It has been hanging in Petrus House in Sussex ever since. We see Brühl sitting with the order of the White Eagle in front of a red curtain. This is gathered and offers a view of the sea with the ship in the background. Here, you see it much better than that. On the table, like state insignia, we see a book, a print text, the sextant, and the sea chronometer. The spine here resembles a Marshall baton or a telescope, and the chronometer a crown. The manufacturer of the marine chronometer was a watchmaker Thomas Mudge. He was one of the leading masters of his discipline, constructed a leather escapement, as we still find in many mechanical pocket watches today, and concentrated on the construction of marine chronometers. Unfortunately, we will not hear Zalabaldi's paper on the leather escapement and Count Brühl today here. In 1714, the English government set up the Board of Longitude, an authority that offered prize money for £20,000 to anyone who could accurately determine the longitude at 6. John Harrison, an English carpenter and self-taught watchmaker, received half of the prize money for his sea chronometer, known as H4. He received only half because astronomers doubted that several indical timekeeper could be built with equal good measurement results. Therefore, in 1775, the requirements for the prize were changed. And from now on, 2 timekeepers of the same design were to be submitted for examination. For these reasons, Thomas Mudge built 2 identical sea watches between 1776 and 1779, which he refers to distinguish from according to the color of the cases, the blue and the green chronometer. Both were subjected to various tests in the following years, but with unsatisfactory results. Nevertheless, Mudge was about 500 pounds for his leather escapement. The invitation of the free leather escapement around 1757 and the escapement with constant force are among Thomas Mudge's outstanding achievements that qualified him for this task. Through the mediation of Count Brühl, the copy number 18 is one of these instruments, delivered to the MPS in 1803. The copies were made by Mudge's son of the same name. In 1794, the lawyer, Thomas Mudge Jr., had founded a manufactory in London to build marine chronometers in series for sale according to his father's model. For this purpose, he hired some precision mechanics who produced about 26 marine chronometers in 1799. Brühl published Mudge's leather escapement in various writings and became his most important supporter. These writings can also be seen in the portrait here and in the book. The sextant may have been made by just Ramsden. Ramsden was an instrument maker who was probably supported by Brühl without considerable financial contributions. The 3-master ship in the background of the portrait could be the Admiral ship of John Campbell, who was commissioned to test Mudge blue and green at Brühl's request. It is not until the end of the 1770s that watchmakers succeeded in further development of free leather escapement, including Joshua Emery, who was also promoted by Brühl. Last but not least, the network maintained by Brühl offered a helpful sales market for the products of craftsmen he promoted, and you find instruments by these 3 persons all over Europe, mostly in observatories. And my last slide, the marine chronometer, which was transmitted from Brühl to Dresden, served the time service as a portable watch, with which the time determined in the Dresden Swinger has delivered to subscribers once a week. However, it also served as a training device for the watchmakers who worked in the Mathematisch-Physikalischer Salon to promote the quality of the clocks and watches built in Dresden for a long term. This can still be seen today. Ferdinand Adolf Lange founded a pocket watch manufactory in Glashütte in 1845, learned his trade in the Dresden Swinger. The watchmaking tradition he initiated still exists today. Some of the best wristwatches in the world are still built in Saxony. Thank you very much.
Thank you so much for your intensive presentation and for your incredible and precious collection. You can your catalog, very interesting and wonderful collection of scientific instruments. We have time for just one question.
Sì, complimenti per questa bella presentazione. Credo che io sono un cultore di questo tipo di strumentazione scientifica, anche rinascimentale e post-rinascimento come questo, e credo che sono tutti pezzi ovviamente eccezionali e anche originali, pezzi unici che fanno la storia di un certo tipo di strumentazione scientifica e di una certa filosofia anche. Ecco, la domanda è questa. Qui siamo al top proprio, diciamo così, di una rappresentazione anche diciamo, strumentale, scientifica, ma che non rappresenta però, cioè, la parte più generale, quella di comunicazione, so, alle classi dei ragazzi, per esempio, cioè, ai giovani, che questi oggetti sono ovviamente eccellenze e quindi tanto di cappello perché sono... Però ecco, c'è anche una programmazione scolastica con materiale più, ecco, più dozzinale, cioè da usare o da far vedere anche.
Yes, we have, of course. We have 3D animations of objects. We have hands-on objects. We made some copies, original copies of historical instruments. We have a vacuum pump. We have electric devices. We have copies of microscopes, and we study it to see how an instrument worked, what's the pros, what's the contrast in 16th, 17th, 18th century, and of course we use it to teach.